going to, there we are. Okay, so I realized that there were some technical difficulties today with the technology and kids being at home and in person, and it was just kind of crazy. So I'm going to record the entire math lesson again. So it also helps because I had some brain fog earlier, and I think a few of us other people did too. So our topic is Math 1-9, and it's called Using Expressions to Describe Patterns. And I just said here it sounds fancy. It's really not that fancy. It's talking about patterns. So patterns can be shown in many different ways. Skip counting is probably one of the first math patterns you learned. You may think of it as counting by twos, and here I just gave you an example. 2, 4, 6, 8. So that is a counting by twos pattern. But now that we are in 6th grade, we would call it a times 2 pattern, or a 2x, or 2 in parentheses x pattern. The variable x is the blank. It's the unknown number. So remember, the variables are what we do not know. The coefficient is going to be the number in front of the variable, which in here is 2. And it's what we are multiplying by. So remember, coefficient goes with multiplying problems. So we're still talking about counting by twos, but we're now doing it in a 6th grade way. So instead of saying 2, 4, 6, 8, we call it a 2x pattern. And then if we want to solve it, we can substitute any number for the variable. So for example, if x equaled 10, the equation would look like this. All right, so I added a slide here. The function table of the same pattern would look like this. Many times this middle column is not there. In fact, I don't think I've ever seen it. It's usually just the input and the output. So a function table is sometimes called an input-output table or an in and out graph. It shows a pattern that follows a rule. In this example, the input, which is here, is being multiplied by 2 to get the output. So the rule is a times 2 pattern, which is exactly what we just talked about right here, a times 2 pattern. In this table, the rule is given to you, but in problems below, you will have to figure out the rule by looking at the pattern. We'll get to that in just a minute. So let's go over some of that vocabulary. So a function table is also called an input-output table or in and out chart, graph, whatever. Whatever you call it, it's the same way to solve it. Every in-out has a rule. And I'm just keeping it as in-out because it's easier just vocabulary-wise. So everyone has a rule. In this situation, the rule was a times 2. The rule tells you what to do with the numbers, how to solve the problem. The input is what you replace the variable with. So let's look back. The variable, so here if I had, let me pull this up, my rule is 2, x. I am going to replace my x with 1. Then in the next problem, I'm going to replace the x with a 2, and then a 3, and then a 4. So, clear. And goodbye. The output is what you end with, or the answer to the problem. Input is always listed on the left side, and the output is always listed on the right side. Left, right. And then in below, you'll see a top and bottom one too. Let's go on. So let's practice function table, but instead of the times 2 pattern, we're going to do a 5s pattern. So remember, we are going to substitute the x for the numbers in the input column. I need to check here, okay. Make sure everything's okay. So here at the top, it says my rule. My rule is 5x, or a different way to write it. So what I'm thinking here is I'm taking 5 times whatever is the variable. Oh my goodness, that is really bad. So I give up on that one. So what my brain is thinking, this would be easier. This is what my brain is thinking. I take that 2 and I put it here, and that means multiply. So my out is a 10. Input, what my brain is thinking is take out the x and put the 3. I get 15. Same thing for 4. I take out the x and put the 4 in there. I get 20. And then for the 5, I take out the x and put the 5 in, and I get 25. So let's take a look at some other ones. Not all function tables are multiplying. Some are adding, some are subtracting, and some are dividing. So the first thing you're going to do is I just go down the list. I add, subtract, multiply, divide. So I say, I'm starting with 1. What do I do to 1 to get 5 when I add? I would add 4. So what I do next is I go down to my next one and say, if I have 3 and I'm thinking it's an add 4, so right now I'm trying out an add 4. So I'm taking 3, I'm adding 4, and I get 7. So that works there. It works there. I'm going to keep testing. 4 plus 4 is 8. 7 plus 4 is 11. 8 plus 4 is 12. So my pattern would be, or my rule is a x, which is our variable right here, the n, plus 4. So let's look at the next one. 0. Well, I could add 0 to get 0. But let's see if it works for the next one. 5 plus 0 is 45. That won't work. I'm seeing that this can't really be a subtraction one because the numbers over here are getting bigger. So since these numbers are small and these are getting bigger, it's definitely telling me I'm going for an adding or a multiplying. So I already tried adding and it didn't work. So 0 times what gives me 0? 0. Okay, I don't know. So I'm just going to keep going. Like 5 times what gives me 45? 5 times 9. So I'm going to check and see it's a times 9 pattern. So that's times 9. 6 times 9 is 54. 9 times 9 is 81. And 11 times 9 is 99. So my pattern is correct. It is a times 9, but we have to write it with the 9 first and the x last. So there's your 2 options on how to write it. Okay, now I'm looking here and I'm starting with a bigger number and I'm getting smaller. That tells me it's either going to be a subtraction or a division. So I'm going from big to small. It's either going to be subtraction or, oh, that is a very ugly division sign. So let's see. 6 minus 3 equals 3. Let's see if it works for the others. Let's see if it's a minus 3 pattern. 8 minus 3 is 5. 14 minus 3 is 11. Yep, it works. So my pattern is a x, whatever I have here in the n, minus 3 pattern. So just remember the n is our x. Clear that up. So that was our variable x. This was our variable x. And this was our variable x on this side. All right. Again, I'm in the situation where I'm starting with something bigger and getting smaller. So again, I'm either going to subtract or divide. So 4 take away 3 will give me 1. Let's see if that take away 3 pattern works. 20 take away 3. Nope, it does not. So I need to find a different pattern. Subtraction won't work. Now I'm on my divide. 4 divided by 4 gives me 1. 4 cookies, 4 kids, everybody gets 1. See, does 20 divided by 4 give me 5? Yes. 32 divided by 4 is 8. 36 divided by 4 is 9. 44 divided by 4 is 11. And that means our pattern is our rule is my x, which is my n. We're taking whatever we have in our n and we're dividing it by 4 to get the answer. So I will make a quick video doing the last slides just so you have the answers, and I will see you guys later.